Welcome to another of my videos where I work through and explain A-level Physics multi-choice questions. If you want to try this question yourself, press the pause button now. If you got the answer D, congratulations, give yourself a pat on the back. If you want to see my explanation of how I found the answer, please continue watching. So first of all, I'm going to zoom in so we can see the question more clearly. So I have a non-uniform sine is 0.8 meters long and has a weight of 18 newtons. It's suspended by two vertical springs P and Q. The springs obey Hooke's law, and the spring constant for each spring is 240 newtons per meter. The top end of spring P is fixed, and the top end of spring Q is adjusted until the sine is horizontal and in equilibrium. It's good that they've made it horizontal because it means that this weight is acting 90 degrees to the sine, and this spring is also 90 degrees to the sine. What is the extension of spring Q? So to solve this question, I need to take moments, and I'm going to take moments about that point there. Taking moments about that point there means I'm acting as if that point is the pivot. If an object is in equilibrium, then the moments about any point, the anti-clockwise moments and the clockwise moments about any point, will cancel out. So I can say that the clockwise moment will equal the anti-clockwise. So taking moments about P, what's trying to turn it in a clockwise direction? It's that 18 newtons, and it acts over a distance of 0.65 meters. So I can say the clockwise moment, is 18 times 0.65. The force produced by the spring Q is trying to turn the sine in an anti-clockwise direction, and that's acting over a total distance of 0.8 meters. So I can say that the anti-clockwise moment is F multiplied by 0.8 meters. Rearranging, I find that the force produced by spring Q is 18 multiplied by 0.65 over 0.8, and that's equal to 14.6 newtons. We're told that the spring obeys Hooke's law, and that the spring constant for each spring is 240 newtons per meter. Well, Hooke's law tells us that the force produced by a spring is equal to its spring constant multiplied by the extension. And it's the extension that we're trying to find. So the extension is equal to the force over the spring constant. The force we discovered was this 14.6 newtons. The spring constant is this 240 newtons per meter. Put that into your calculator and you discover that it's 0.061 meters. As given by question D. I hope you found this useful. If you did, please like and leave a comment below, and I hope you watch more in the series.